Hi everybody. This is a lesson I like to call the science of sound. What you're going to need is a spoon, a plate, glass plate if you have it. If you have a tuning fork, you don't have to have a tuning fork. Okay. The only other thing that you need are some surfaces in your room that have like hard surfaces, like something maybe that's made out of wood, something that's made out of metal, formica, different types of hard surfaces or textures. So you want to have stuff like that nearby when you do this. Okay, so what we're going to talk about is how sound moves, what it moves through, and keep track of that. And see if we can feel sound, see sound, hear sound, touch sound, things like that, okay? How many senses are we going to use when we're talking about sound, okay? So try this test. Take your index finger and your middle finger and put it on your neck, right here, and just say the word ah. Ah. Now say it quietly. And now say it as loud as you can. Ah! Okay. You not only hear the sound, but you can feel the movement inside your throat. When you say ah, your vocal cords vibrate. And that means that they're moving quickly back and forth. As your vocal cords vibrate, they produce a sound. And this is where a tuning fork comes in. If you don't have a tuning fork, you can just listen to this part and then maybe in the future, if you're at a music store, you can pick up a tuning fork. They're not expensive. When the tuning fork is at rest, it's surrounded by molecules in the air. You can't see them, okay? And as a tuning fork vibrates, it causes the molecules in the air around it to move. So the molecules bump into one another. They bump into other molecules that are nearby, causing them to move. So they're all moving. Okay, this process continues from molecule to molecule, and the result is a series of compressions and refractions that make up sound waves. Okay, so sometimes you can hear the sound waves, but can you see them? Can you feel them? Okay, so that's where our tuning fork comes in. So you hit the tuning fork on any hard surface, okay, and then set it on your elbow, set it on your knee, set it on your skull, set it in a plate of water, okay? And find out what it does. Do you feel the sound? Do you hear the sound? Do you see the sound? Okay? So I'm going to hit a hard surface. I don't know if you can hear that. I can hear it and I can feel it in my elbow. I can hear it and I can feel it in my head. I don't know if you can. Okay, so that's what you do with the tuning fork. Okay, molecules are moving around, and that's why I can feel it and I can hear it. Okay, so if you put it on your knee, that's a bone. Skull is a bone. Okay, what would happen if you hit the tuning fork and put it on your belly or your tooth? Okay, so experiment around with that with the tuning fork. Now, the second part of what we're going to do here, oh, and you can also kind of make a chart if you want to and keep track. Okay, what did I hit the tuning fork against? Did I hear the sound? Did I feel the sound? Did I see the sound? Okay, now I can't move my camera around too much, but what you want to do with the water part is put the water in the plate, like so, okay, not too deep. And when you hit the tuning fork against something, you're going to put it like this, just into the top of the water. And I want you to watch the water and see if it moves, okay? That's what the plate is for, okay? So you can do that on your own. Now, what we're going to talk about is, we just talked about the tuning fork and sound, me being able to hear the sound. Can sound travel through things? So what you'll need, like I said before, is a metal spoon, okay, and some string. maybe I would say about 2 feet of string, okay? And what you're going to do is you're going to take a spoon, and I just want you to drop it on the counter or on a table and observe the sound that it makes. Okay, you can drop it on the floor if you want to. Now you know what it sounds like, okay? Now, take the string, and I want you to tie a piece of string to the middle of the spoon, okay? You want to leave about 15 to 20 inches on either end of this string. I've done this activity with a lot of first and second graders, and they love this part. So you wrap the ends of the string around your index fingers, okay? And you have to leave the spoon dangling in front of you, okay? So make sure both ends of the string are taut, like so. Now, you're going to place your index fingers in your ears like this. Now you're going to tap the spoon against the edge of a table or a counter or something like that. So watch me. What kind of sound does it make? Does it sound the same as when you dropped it on the counter? Does it sound the same as when you dropped it on the floor? Okay? Now, do this with the string in your ears like this on your index fingers, okay? And I want you to go around and tap the spoon against other things in the room and observe the sounds that you hear, okay? What happens if you strike things gently? What if you strike things with a little more force, okay? So what if I went really hard against the counter? And how does it sound differently if I do it very gently against the counter, okay? And that's another place where your chart will come in helpful for you, come in useful for you, okay? Chart your observations, okay? How do you think you can hear sounds that the spoon makes, even though your fingers are in your ears? How is that possible? Okay? That's what we want to know. The fun part of all this is walking around the room and knocking it against things and hearing the different sounds that it makes in your ear, if it makes a sound. Some things it might not make a sound. I don't want to give you too many answers here. So, a sound wave moves through matter, such as air, just like a sound wave moves through the spoon that's tied to the string, or a sound wave moves through water, or a sound wave moves through bone. Okay? So, at the beginning, I asked you, can sound travel through things? After you make up your chart, you will have your answer. So I hope that this little Science of Sound unit or experiment is fun for you. And it's also, something you can do at school or at home. And again, we're going through the COVID-19 crisis right now. So I'm sitting here at home trying to think of fun things for some of my students to do at home with their families. And not only is this going to be a nice learning experience, but hopefully it'll be a lot of fun too. And your tuning fork, don't worry if you don't have a tuning fork, you can move right on to the spoon activity. All right, have fun with this and enjoy.